Okay, just a video on basic patterns. So what I've got here is I've drawn out a basic pattern, and the concept that I'm going to use to describe this is table and chairs. So if you imagine that's a table and you've got 4 chairs around it. Okay, 2 tables, you've got 8 chairs, 3 tables, you've got 12 chairs. I can write that out as a list. And that is one way to write out a pattern, and that's what you focused on last week with Miss Farr. So if I do that, and I concentrate initially just on the number of chairs, it would be 4. After that it would be 8. Then it would be 12. And obviously that wouldn't stop there, I could keep going, I could keep on adding another table, which would get me another 4 chairs. So adding another table, giving me 4 tables, that would give me 16 chairs. Okay, adding another 4 chairs with another table, get me 20, and obviously that would just keep going. So what we're going to do today is we're just going to build on that. So as you can see, I've still got my list, and that still describes the sequence in terms of chairs. The only difference with this example is we've now got tables as well. So all I'm going to do is above the number of chairs is I'm going to write in the number of tables. So for 4 chairs we had 1 table. For 2 tables we had 8 chairs. For 3 tables we had 12, and that's where the diagram stops, but like I said, the sequence doesn't. We can keep going. If I had 4 tables I would have 16, and if I had 5 tables I would have 20 chairs. Okay, so now what we're actually looking at is more of a kind of table format, and I'll just make that a wee bit more noticeable by actually drawing in a table. Okay, I'm also going to bring some letters in here so that people know what the rows in the table actually mean. So the bottom row, 4, 8, 12, 16, 20, and it obviously just keeps going. That was the number of chairs. I'm not going to write that down. We're dealing with maths here, so we're going to abbreviate that to C. We're going to use letters. And the top row, well, that was the number of tables. So again, we'll abbreviate that to C. Okay, so we can see that we are still dealing with the lists, the pattern written out in a list format, but we've just moved it on a wee bit, and we're now looking at patterns in tables. By writing out in a table, what it allows us to do is it allows us to write out the formula or the rule for the nth term. You might hear that or read that in textbooks, the rule for the nth term. What they're asking for there is a connection between C and T. Okay, they want a formula that involves C and T that describes this sequence, this pattern. So there's a very set way to do this. You'll hopefully see along the bottom, and in my previous video I highlighted the need to kind of see that and look for that we're going up in force. Like I said, it doesn't stop there, it keeps going on. So the formula follows a set pattern and how to actually write it down. So if I wanted to write down the formula for the nth term or the rule for this sequence, you always start with the letter at the bottom of the table. So the letter on the bottom of the table here is C. So it's C equals. If the letter on the bottom of the table was Y, it would be Y equals. If the letter on the bottom of the table was X, it would be X equals. In this example, it's C. So you always start with the letter on the bottom equals. Then all it is the jumps, and you can see here that we're going up in 4s, times the letter on the top of the table. So the letter on the top of your table is T. Like I said, it doesn't matter if the letter changes, that will always be the rule for writing down the formula for the nth term. Okay, now the good thing about having a formula is we can check it. What we're actually saying here is the number of chairs is 4 times, remember there's a multiplication there, we just don't show it, the number of tables. So let's see if that's true. Well, if I've got 1, if I put in 1 into that formula, 4 times 1 is 4. So that's correct. Same again here, if I put 2 in for T, 4 times 2 is 8. And again, the table's shown that, so that's correct. Same again here. 4 times 3, 4 times 3. If I put 3 in for T, 4 times 3, I get 12. Again, if I put T in as 4, 4 times 4 is 16. And finally, 4 times 5, is 20. So every single column in my table is correct, so that's definitely the correct formula. Now, we don't have to look at it downwards, okay? So as in times in 4, times in 1 by 4 to get 4, times in 2 by 4 to get 8, times in 3 by 4 to get 12, times in 4 by 4 to get 16, 5 by 4 to get 20. We can look at it the other way as well. So if I put in 4 for C, again, if I solve that equation, divide both sides by 4, I would get t equals 1. Again, if I look there, if I put in C is 8, again, if I wanted to solve that for t, I would divide both sides by 4 and I would get 2. Again, 12 divided by 4 is 3, 16 divided by 4 is 4, 20 divided by 4 is 5. So it works both ways. So why do we need the formula? Well, what that allows us to do is actually answer questions a lot more efficiently. So I'm just going to put in another wee column. I'm going to black that out. And I'm going to say, what happens if I had 12 tables? Now, if I don't have this table, what I have to do is carry this sequence on until I've got to 12, and that's quite time consuming. But with my formula, I know that t is 12, so all I do is I say when t equals 12, and we just sub it into the formula. C equals 4 times 12. Okay, it tells you t is 12, so we replace t in the formula with 12, and we get 4 times 12, which is 48. So we would need 48 chairs. And it works both ways, you know. So if, for example, I was told that I had 80 chairs, so again, when C equals 80, and I had to work out how many tables I needed, well, again, all I do is substitute into my formula. We're told that C is 80, so we replace C with 80, so we get 80 equals 4t. Again, we're solving this for t, so just divide both sides by 4 to get t in its own. So we get t equals 80 divided by 4, so we get t equals 20. So I would need 20 tables if I wanted to have 80 chairs.